In this video, we're going to learn how to calculate the volume of three-dimensional shapes. So in the last video, we talked about what a square meter or square centimeter was. So I'll use centimeters as an example. 1 square centimeter is a physical square that is 1 centimeter by 1 centimeter. When we multiply these, we got 1 centimeter squared. Likewise, if we had 3 dimensions, so a cube, this is called a cube, you would need 3 measurements, 1 centimeter, 1 centimeter, 1 centimeter. Now it turns out the volume of this cube, so up here was the area, the volume of a 3-dimensional cube would just be multiplying all of these lengths together. And that would make 1 centimeter to the power 3, which is actually called cubed. We already called that a cubed centimeter. So you can see why it was called a cube. The same reason that squared was called a square. It all has to do with geometry. So in this example, we have this shape, and we're asking how many cube centimeters can we fit inside the shape? So just like with area, there are just formulas that can do this for us. So the volume formula for this shape, which is called a rectangular prism, rectangular because it's a rectangle in its base, and a prism just means that it extends the same shape throughout the third dimension without changing the shape of the base. So it's just a rectangle all the way through. So the volume of a rectangular prism is equal to the length times the width times the height. And it really does not matter which one you choose as which, because again, multiplication does not really have a particular order. 3 times 2 is the same thing as 2 times 3. So I'm just going to put the 3 lengths that I see here, which are 1 centimeter times 3 centimeters times 2 centimeters. 1 times 3 times 2 is 6. And centimeter times a centimeter times a centimeter is a centimeter cubed. So it turns out this shape can fit 6 of these cubic centimeters in it. That's how we get 6 centimeters cubed, or 6 cubic centimeters. And this is our final answer. Next shape here, this is another prism. You can see because the same shape exists throughout the third dimension, but this is a triangle in its base. So we would call this a triangular prism. Makes sense, I hope. Now, it turns out for any prism, all you have to do is calculate the area of the base. I'll do that. So the volume of a prism of some kind is just going to be the area of the base times I guess we can call it the width or the height. I'll call this the height. I know it's sitting down, but generally you'll see it mentioned as height. So all we have to do is calculate the area of the triangle and then multiply it by this 12 meters, which we call the height. Do you remember how to calculate the area of a triangle? Well, for a triangle specifically, it would be the length times the width divided by 2. So the length and width are both 10 in this example. So this would be 10 meters times 10 meters divided by 2 times a height of 12 meters. Well, this is just some math to do. I'm going to put this over 1 because that's how we multiply fractions by other fractions. 10 times 10 times 12 is 100 times 12, which would be 1200 or 1200 meters cubed over 2, which if you do that division, you get 600 meters cubed. This would be our volume. So we can fit 600 cubic meters in this thing. So this shape is called a cylinder. Now, a cylinder technically is just a circular prism. It makes sense because the base is a circle and it's just extended as the same circle throughout the entire shape. So, likewise, the volume of any prism is just the area of the base, this is what we saw above, times the height. What's the area of the base? Well, the base is a circle of diameter 7 meters. So the circle of the base looks like this, a circle with a width of 7 meters. That would mean that the radius is half of that. It's half of that diameter. So the radius is half of 7, which would be 3.5 meters. And the area of a circle is pi r squared. Pi times r squared. So this would be 3.14 because that's what pi always is. The radius is 3.5 meters times 3.5 meters because it's squared times the height, which is 10 in this example. What does this make? Well, let's put this into a calculator. So 3.14 times 3.5 times 3.5 times 10. So I'm getting 384.65 meters cubed. So keep an eye out for any prism. As long as you know how to calculate the area of the base, you can answer the volume of pretty much any prism. However, this question here is not a prism. This shape is not a prism. This instead would be called a pyramid. So we call this a square pyramid. And pyramids come in different shapes. You know, the base here is a square, but it didn't have to be a square. We could have had a circular pyramid, which is also called a cone. We could have had a triangular pyramid, which makes a tetrahedron. We could have a rectangular pyramid, you know, all sorts of pyramids. The point with a pyramid is that every, I guess, corner or every side, everything meets up in the top as one point. And that's all you need for a pyramid, is they all meet at the very top and they make a point. So pyramids, it turns out they follow a similar pattern with calculating volume. So the volume of a pyramid is the area of the base times the height. It's just divided by 3. That's the only difference between the volume of a pyramid and the volume of a prism. So a prism we do not divide by 3, but a pyramid we do divide by 3. So, okay, we just need to find the area of the base, and that's not going to be too difficult because the area, well, the base is just a square. So the bottom of this thing is just a square where all the sides are 3 meters. So the area would just be 3 meters times 3 meters, using the formula for a rectangle, times the height, which is 5 meters. All of that divided by 3. So 3 times 3 times 5 would be 45 divided by 3 meters cubed. 45 divided by 3 is 15 cubic meters. So that will be the case for many pyramids. You just do area of the base times the height divided by 3, and you'll get your answer. All right, this one is going to be a bit trickier. So let's suppose that this one had, let's say the height and width were both 10 meters. Let's say everything here was 10 meters. And let's say that I only gave you the distance from here to here, here to here, here to here, and here to here, and they were all 1 meter. Sometimes we have to solve this puzzle a little bit. So it's hard to tell with this picture, but what I mean by this is there's a hole that's cut out here, and the hole goes in here. So I want to know what the volume of this object is in the locations where it is not cut. So this location here, you know, all of this, all up here. What would that volume be? I guess the first question is, what is the radius of this circle? Or what is the diameter of the circle first? If we know that the height of this cube is 10 meters, and we know that we're taking off 1 meter on the bottom and on the top, it would make sense that the diameter would be 8 meters. Therefore, the radius would just be half of the diameter, which is 4 meters. So we have two problems to solve here. We have to solve both the volume of the cube and the volume of the cylinder. So the cylinder is the circular prism that's going on here. And the cube is the cube that's on the outside. So let's figure out the cube first. I think that one will be the easiest. It's going to be length times width times height. And everything is 10. So 10 meters times 10 meters times 10 meters. Well, 10 times 10 times 10 is 1,000 meters cubed. The cylinder, on the other hand, is going to be a bit different because it's going to be the area of the base times the height. The area of the base would be the area of a circle, which is pi times r squared, then times the height. And the radius we said was 4 meters. So 3.14 times 4 meters squared, so times 4 meters again, I'll say, times the height, which is 10. Let's put that into a calculator and get 3.14 times 4 times 4 times 10, 502.4. So a little over half of this is cylinder. But recall that we cut a hole in the middle of the cube, and that means we're removing 502.4 cubic meters from the shape. So if we wanted to get the total volume that's left in the remaining part of this cube that hasn't been removed, we have to do a subtraction. So the volume remaining would be the volume of the cube minus the volume of the cylinder, which would be 1,000 meters cubed minus 502.4 meters cubed. This results in 497.6 meters cubed. And that's it for pre-algebra. So please review all of the material in the previous videos, and I will see you in the next unit.